Okay, this is for 5.4 Objective 2, Square Binomial.
Let's now take a moment and study this example and see if we can see another pattern occurring. Notice this is a binomial squared. And notice the result when we square this binomial. This first term is the first term of the binomial squared. In other words, this term is 5x times 5x. 25x squared. The last term is the last term in the binomial squared. 9 times 9 is 81. And you may have a hard time seeing this, but this middle term is 2 times the first term times the last term. 2 times the first term in the binomial times the last term in the binomial. 2 times 5x is 10x. 10x times 9 is 90x. This pattern occurs every time we square a binomial. So let's look at the following pattern or special product. This is a special product for squaring a binomial. A binomial squared. So I have a plus b quantity squared or a minus b quantity squared. It's equal to the square of the first term and then plus or minus, depending on the sign between the two terms in the binomials, twice the product of both terms, and that's in the binomials, plus the square of the second term. Let's now square this binomial using a special product. Now, by the way, don't forget, if you'd like, you can write down 2 factors of 2x minus 1 and use the FOIL order for multiplying. That always works with multiplying a binomial times a binomial. But we're going to use the special product we just looked at. So I have a binomial squared. Remember, it's equal to the first term squared. So if you'd like, I can write down 2x quantity squared and then plus or minus, in this case minus because it's 2x minus 1. So minus twice the product of 2x, that first term, and 1, that second term, and then we have always a plus, the second term squared. That is a pattern for squaring a binomial. So let's write this down. 2x quantity squared, that's 2x times 2x, or 4x squared, and then minus 2 times 2x times 1, that happens to be 4x, plus 1 squared is 1. This is the product. Notice there's no like terms that can be combined, so this binomial squared is that trinomial. There's also a special product when multiplying the sum or difference of the same two terms. Let's look at an example of this and see if we can understand or figure out the pattern ourselves.